Hello, today we are going to be working on linear or nonlinear tables. So that's really our question. Is this table a linear function or is it nonlinear? So the basic concept we need is that slope is the constant average rate of change. The formula we often use is y2 minus y1 over x2 minus x1. And we also, which we're going to be using today, use this formula, the change in y over the change in x. So we're going to start by looking at this table. I'm going to begin by identifying the change in y. So am I increasing from one to the next, decreasing from one to the next? That's what I'm looking at. So from 2 to 4, I have an increase of 2. From 4 to 6, also an increase of 2. And from 6 to 8, an increase of 2. When I take a look at the x's, I have to do the same thing. So from -1 to 0 is a +1, +1, and +1. So that's not it, because we did not actually determine the average rate of change yet. All we did was determine the change in y over the change in x. So what's in green is my change in y, and what's in red is my change in x. So I'm going to put them together in this format, the change in y over the change in x. So that's when I'm actually determining the average rate of change. So I'm going to make another column off to the side here that represents the change in y over the change in x for each set of points I looked at. So for the first two, I have +2 over a +1, which reduces to a 2. Then I have another 2 over 1, which is also 2. And the last one, which is a 2 over 1, which is also 2. So this is a linear function because no matter which 2 points I choose, I will always wind up with an average rate of change that is 2. So our answer is linear because it grows by equal differences over equal intervals. It has a constant average rate of change. So let's take a look at the next example. We have -1, 0, 1, 2, and then 3, 6, 10, 15. So we're going to do the same process. We're going to start with the change in y. So the change in y is +3 from 3 to 6, from 6 to 10 is a +4, and from 10 to 15 is +5. Now we have to work on -1 to 0, 0 to 1, 1 to 2, which are all going up by 1, and that is our change in x. So now we need to put it together to determine the average rate of change. Once again, that is the change in y over the change in x. So this will be 3 over 1, which is 3, 4 over 1, which is 4, and 5 over 1, which is 5. This is nonlinear because we do not have a constant average rate of change. Every single time I pick different points, I wound up with a different average rate of change, which means it's not constant, so it is nonlinear. And this is what we would say for nonlinear functions. It's nonlinear because it does not have a constant average rate of change. So by saying we do or we don't, we will determine whether we have a linear or nonlinear, because linear functions must have a constant average rate of change, and every other type of function will not have this constant average rate of change. So that's how we can determine whether it is or not. So now let's take a look at number 3. We're going to do the same thing and then use one of these explanations for whether it's linear or nonlinear. So we're going to start with the change in y. And just by looking at it, I might say, well, no, it's not linear because look, these don't have a pattern. But they might. We have to check. We still have to do this work and determine the average rate of change between each set of points. So from 10 to 6 is -4. From 6 to -2 is -8. And from -2 to -4 is going down by 2. So now we're going to take a look at our change in x. I go up by a +2, +4, and +1. So our final step is to determine the average rate of change between each set of points, which is the change in y over the change in x. So I wind up with negative 4 over 2, which if you need your calculator by all means, but negative 4 divided by 2 is negative 2. Then we have the next 2, which is negative 8 over 4, which is also negative 2. And negative 2 over 1, which is also negative 2. So once again, I do have a constant average rate of change because I am constantly going down by 2 over 1, technically, for each average rate of change. So it is constant, so I would use this response to explain my work if I needed to. Okay, thanks. Bye-bye.